Assalamu alaikum everyone. I'm Qazi Ashikur Rahman and today we will be presenting our final project, line following robot with PID algorithm for our 461 course. So for our final project, first we need to create a new world, and to set up our environment first, we need to deal with the background and background lights. So from the add button, we will be selecting the object, and from there we will be selecting the texture background from the background. Again, from the object and background, we'll be selecting textured background light for our lighting purpose. So then to our line, and to work with our line and robot, we need to set up a rectangular area. So from add object, we will be selecting the floor, and from there we'll be selecting solid rectangle arena. Then we need to adjust the size. So for that, we will be selecting the floor tile size under rectangle arena, and we will be changing the parameters over there. After that, we need to work with the robot. So in our pre-built robot, we already use distance sensors or infrared sensors, so we'll be using that here also. That pre-built robot will be using here too. But now we need three distance sensors. So three distance sensors will be used here. We just followed the same procedure as before for these sensors, but just reposition them along the axis. Then for the line, we need to create our desired track as required left and right turn in Autodesk Tinkercad. So we will be adjusting the height over there for sure, because it was a bit too high for the environment that we were using. Then we will just export and import the 3D model object file in our environment. Then for getting better value, we selected white color from the material section from floor appearance. We had selected white color to had a good contrast with our black line and get a better value. Then after importing that line, we resized and translated that track accordingly to adjust it according to the rectangular arena that we had. Then we need to align our robot along the line so that it can follow. Then we need to work with our controller and code part, and it will be discussed by my other teammates. Thank you.
Assalamu alaikum. My name is Hamza Medshad, and I will be discussing what exactly is a PID controller. Well, PID controller stands for proportional, integral, and differential controller. It is a loop mechanism that is solely based on feedback and a target set point. What that means is that we will put some set points which will go through a system and give us an output, and then we feedback that output into the input. Let's talk about the process of PID. Well, the first step is that we put in some basic set points that the PID will first use. Then we do some basic computation that it gets from that feedback of the output. Then that output feedback is then applied as an error to PID. The proportional part of the PID will be Kp into the error. Then the integral part will be Ki, the integration of that error, and the differential would be the Kd into the differential of that error. Then we get we get a value from that process. Then we put from that output, the robot acts accordingly to that output. Thank you. Now the code part will be discussed by my next teammate.
Assalamu alaikum everyone. My name is Nashita Bint Asad, and I will be explaining the code that we have used for the controller for this line following robot. First, we set up our time step and our maximum speed for the robot. Then we have also initialized all the wheels and the sensors. We have 3 sensors here instead of 2 as our last project. And to initialize our Kp, Ki, and Kd values for our PID, we used arbitrary numbers, which works for this code that we run here. We also, in the beginning of our code, we initialize the last error to be 0. The last error changes at the end of our code and code inside the while loop. So once the while loop starts, it starts as a time step is given as not equal to -1. So it will run as long as we want it to. Here I have initialized the IR values for the sensors as DS1, DS0, DS1, and DS2, and then the actual part of the sensors is used. Here we can see that we have put in some conditions, if, else if, and other conditions. Here we can see that we are getting a value of around 540 to 545 for the white background, and when the sensor is on the black line, we get a value of 1000. So for this reason, I have put in 650 for so that whenever we get white background, it is always the condition of being less than 650 is always held true. Or if it is greater than 650, then we know that the line is on the black line. So using these values, we put in some conditions that if condition 0 is when the middle sensor is getting the black line, and then if the right sensor is getting the black line, then we have put in the error as -1, and then for the black line to be on the left, we have put in as an error of 2, and so on and so forth. Using these error values, we then can compute our PID equation. So the error variable starts with an error of 0, and then we also have initialized the integral and differential variables for error is equal error plus int, error minus last error. Then we use the equation for the PID, which is balance is equals to Kp into prop in plus Ki into int plus Kd into differential. And we set the last error to the true error. Next, we change the left and right speed accordingly. The left speed is the maximum speed minus the balance, which we just calculated, and the right speed is maximum speed plus balance, which we just calculated. According to these values, if the left speed is greater than max speed, then we know that we need to turn the robot to the left. If the value of the right speed is greater than max speed, then we know that we need to run the code. Then we can see that our robot follows the line according to the code, and it always tries to keep on top of the black line, as is the function, as was the problem that we were given in our project. As we see, the robot can go through the entire loop without any problems, and it can handle both left and right turns. Thank you.